Welcome to EduCasts, home of EduCasters. So we know the theory and we know the pitfalls. How do we actually do this in a real classroom on a Tuesday morning? It's not about becoming an artist or redesigning your entire curriculum. It's about small, strategic shifts in how you present information. 1. Timelines and processes. In history or literature, endless strings of dates and events can be numbing. A narrative, verbal, is great, but a timeline, visual, organizes that verbal information spatially. If you are teaching the American Civil War, don't just list the battles. Create a visual timeline where the North is on top and the South is on the bottom, with arrows indicating movement. By spatially organizing the data, you allow students to see the flow of the war. They can use their visual memory to recall that Gettysburg was in the upper right, which helps them situate the event in time and importance. 2. Dual coding in math. Math is naturally abstract. Numbers are symbols. To dual code math, we need to make it concrete. This is why manipulatives are so big in early education, but we often abandon them too soon. In algebra, the concept of a slope, y equals mx plus b, is purely verbal symbolic. But when we graph it, it becomes visual. Teachers should explicitly link the two. Don't just draw the graph and then write the equation. Point to the b in the equation and then point to the y-intercept on the graph. Say, this number here is this dot here. Trace the rise and run of the slope with your finger while explaining the ratio. You are physically weaving the visual and verbal threads together for the student. 3. Sketchnoting and graphic organizers. Dual coding isn't just for the teacher, it's for the student too. We should encourage students to use dual coding in their notes. Sketchnoting is a fantastic strategy where students draw simple icons or diagrams next to their written notes to represent the main ideas. If they are learning about friction in physics, they might write the definition and draw a rough sketch of a box on a rough surface. This forces the student to engage in generative processing. To draw the concept, they have to understand it deeply enough to visualize it. It moves them from passive consumers of information to active creators of mental models. Graphic organizers, Venn diagrams, mind maps, flowcharts are the bread and butter of dual coding. They take verbal relationships, comparisons, sequences, hierarchies, and turn them into visual structures. A hierarchy chart of the federal government is infinitely more memorable than a paragraph describing who reports to whom. 4. Diagrams in science. In biology, chemistry, and physics, processes are key. Photosynthesis, the water cycle, electron orbitals. The standard textbook approach is often dense text. A dual coding approach prioritizes the diagram. The Cavaglioli method, named after Oliver Cavaglioli, a modern champion of visual teaching, suggests stripping away chart junk, unnecessary decorative borders, clip art, or distracting colors. Focus on the signal, not the noise. Use simple line drawings. Use consistent color coding. If the oxygen molecule is red in the first diagram, it better be red in the fifth diagram. This consistency reduces the cognitive load required to identify the parts, allowing the student to focus on the process. As with any educational theory, we have to talk about the limitations. Dual coding is powerful, but it is not a magic wand. First, the image must be relevant. This is crucial. In the early days of multimedia, people thought, I need an image to make this slide interesting. So, if the slide was about business growth, they'd slap on a stock photo of a guy in a suit high-fiving someone. This is called a decorative image. It adds zero educational value. In fact, it can be a seductive detail, something that draws attention away from the actual learning material. If the image doesn't directly explain, organize, or interpret the content, get rid of it. A blank slide is better than a distracting one. Second, we have to consider the expertise reversal effect. What works for a novice might annoy an expert. A novice mechanic needs a diagram showing exactly where the spark plug goes. An expert mechanic just needs the specs. For the expert, the diagram might be redundant and slow them down. As educators, we need to fade out the support as students become more proficient. Third, you have to deal with the truly abstract. How do you dual code existentialism? You can't exactly draw a picture of it. In these cases, we have to rely on metaphors and analogies. We use a visual of a roadmap to explain life choices, or a visual of a heavy burden to explain guilt. The image isn't a literal representation, but a metaphorical anchor. Education is a messy human business. There is no algorithm that guarantees a student will learn. But as we move further into the 21st century, we have to base our practices on how the brain actually operates, not on folklore or tradition. Dual coding theory offers a clear, evidence-based path forward. It tells us that our students are capable of robust, durable learning if we respect the architecture of their minds. It tells us that words are powerful, but words coupled with images are unstoppable. By combining the verbal and the visual, we are essentially doubling the odds of success. We are giving students two keys to unlock the same door. Whether you are teaching a 6-year-old to read or a 30-year-old to code, the principle remains the same. Don't just say it, show it. Don't just show it, explain it. When we integrate these two channels, when we stop forcing students to choose between reading and seeing, and instead let them do both, we reduce the cognitive load, we bypass the bottleneck of working memory, and we lay down deep, interconnected,